discovered property of space-time.
Or is there something wrong with the data? So
is there
are
something
models off? Do we trust the data, or do we need new physics?
But if the data's off, the model's off by definition. No, maybe no.
I spent time at Princeton where they have a lot of theorists. They say never trust an observation unless it's backed up by a theory.
Okay. Well, that's happened. I know of 2 cases where observation was made and it did not fit with the theory. I'll give a very simple one. It was Art Walker's research. When he first got the images, so when you see the pretty images of the sun with the plasma loops, Art did that first, right? And so the plasma loops had a constant cross-section. And so the solar physicists were like, dude, there's something wrong with your telescopes because we know magnetic fields diverge with altitude. So they should get fatter at the top. They're not getting fatter.
But just to be clear, so the magnetic field is confining the plasma.
That's right.
So the shape of the plasma is the shape of the magnetic field.
Exactly.
And so he's saying that the magnetic field is just a constant cross-sectional tube.
That's what
but it should be something more dynamic than that.
Yeah,
okay.
at the top they should get fatter, right? Just like if you
The
look at a
theory
bar
said that.
magnet. Theory said that, right? And Art was like, ain't nothing wrong with my telescopes. So what I'm going to do is I'm going to have the same passband, but I'm going to give you 3 different configuration telescopes. I'm going to give you a Cassegrain, a Herschelian, and a Ritchie-Chrétien. So you can't say it's the optics. And not only that, so we would fly 16 to 22 telescopes with all these passbands, which ended up being a subset of them, the same passbands on SDO and EIT, the solar satellites, and showed, no, this is what nature is doing. It's not an issue with the passbands. It's not an issue with the optics. This is what nature is doing. And now that's what everyone knows.
So the theory had to be adjusted.
The theory had to be adjusted. Right,
okay,
right. You had to come
cool.
up with a mechanism.
Yeah, so it can happen. So let's get back to Hubble tension.
Hubble tension, right? So people have
There's been a lot of articles.
There's been a lot of articles, right? And so essentially,
and everybody wants to just throw out the Big Bang. That's
throw out dark energy.
That's
clickbait.
Clickbait.
Yeah, right.
Okay.
Exactly. It's clickbait, right?
Yeah.
So essentially, what's been happening is you have the cosmic microwave background radiation, which has been a treasure trove of cosmological information. Then you have the standard way that we measure expansion. I have some object. I know
how fast it's moving.
How fast it's moving away. It's redshift, and I also know its distance based on its brightness. Right. And so now I can make a Hubble diagram. I fit the Planck data. I get a value of the Hubble constant. They don't agree.
But the Planck is the cosmic background. Yeah.
Right.
The Planck satellite from Europe. The European
satellite. I be saying stuff. Don't even know. I be leaving stuff out, man.
That's why I'm here.
That's why you're here. Thank you. Yeah. So
to keep you continuous.
So now there's new James Webb Space Telescope data.